Assalamualaikum guys, I hope you are fine, and it's almost 10 minutes and there are just 18 and 19 students in the class. I'm going to download the attendance now, and all those students who will be coming late in the class after this, they will not be marked attendance. I will just check the attendance at the end of the class with this attendance, because this is not that we have to wait so long for the class. Bismillahirrahmanirrahim. Let's start with today's lecture. Last time we were studying principal stresses and maximum in plane shear stress. We have derived the equation to calculate the orientation of the principal planes, and as we have said earlier that the normal stresses on the principal planes, they will be over principal stresses, major principal stress and minor principal stress. And then we have to calculate the orientation of the shear plane over which you will get the maximum in plane shear stress. So last time we have covered half of it. We have done this principal stresses. So if you recall, we have said that to calculate the orientation of the principal planes, we have to first take the derivative over of equation 1 with respect to theta. Equation 1 is over equation for computation of transformation of the normal stresses about x dash axis. That was sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. So we will derivate this equation with respect to theta. So this is your derivative. Then you will equate that derivative equal to 0, and then after simplification we will get this final expression. So this derivation we have already covered in our last lecture. Now the other thing which we were studying, that was that this equation tan 2 theta p, it will give us two roots. The solution has two roots, one theta p1 and other theta p2. As we studied last time, that tan, it will be positive in two quadrants, quadrant 1 and quadrant number 3. So this tan is positive in two quadrants, quadrant 1 and quadrant 3. So you can see this, this will give us the positive results, 2 times tau xy over sigma x minus sigma y. So both the terms are positive. So the difference between theta p1 and theta p2, it will be 90 degrees, but the difference between 2 theta p1, let's say 2 theta p1 will be in the first quadrant and 2 theta p2 will be in third quadrant. So the difference between these two values of 2 theta p1 and 2 theta p2 will be 180 degrees apart. So the difference between theta p1 and theta p2 will be 90 degrees apart. Fine. So this is what we have studied last time. Other thing which we have to discuss was this triangles, which we also discussed last time, that the values of theta p1 and theta p2. One way to calculate the maximum normal stress, maximum and minimum normal stress, is to equate the values of theta p1 and theta p2 in our equation number 1. Now, because we are going to substitute the values of the orientation of the principal plane, so the stresses that we will get, they will be over normal stresses, maximum principal stress and minimum principal stress. So the values of theta p1 and theta p2 must be substituted into equation 1, and we can also get the required normal stresses. In this case, these values of theta p1 and theta p2, they will give us the maximum normal stress and minimum normal stress, which is over major principal stress and minor principal stress. So further to do this, now we are going towards the derivation. Other thing which we have discussed last time, that was about this figure, that you can see this shear stress and the average of the difference of the normal stress are either both positive or both negative. They are either both positive or both negative, and this is your 2 theta p1 and this is your 2 theta p2. The difference between 2 theta p1 and 2 theta p2 is 180 degrees. Other thing is this resultant. Resultant of this angle will be sigma x minus sigma y over 2 square plus tau xy square under root of this. Okay, so this was what we have studied last time. If you have any question about this, please let me know, and then we can start with over today's lecture. Any questions?
No, sir.
Okay, now next thing is we have now this orientation of the principal planes. We have this orientation of the principal planes, like if from this equation we can get the orientation of the principal planes, that is theta p1 and theta p2, and if we substitute these values of theta p1 and theta p2 in our equation 1, we will get the major principal stress and minor principal stress. Now, moreover, we are now going to derive an equation in which, from which you can directly get the principal stresses, major principal stress and minor principal stress. We will directly get major principal stress and minor principal stress. So let's start that part. ठीक है जी. Only thing again here I'm repeating, which needs to be remembered, both shear stress and difference of average of normal stress, they are positive, and over here shear stress and difference of average of normal stress is negative. So these are both negative, these are both positive, so this is the resultant. ठीक है जी.
एक्सक्यूज मी सर.
जी
हेलो सर, वो मेरे एक दोस्त का नेट चला गया, वो कह रहे काइंडली आप एडमिट कर दें. वो नेट चला गया था तो लीव हो गई, अब दोबारा एडमिट नहीं हो रहा.
Jawad, while I'm teaching, ठीक है, if you have questions related to the lecture, only ask those questions. ठीक है, please do not tell me what to do. I know that this is not the way that teacher is waiting for 10-12 minutes and we are ready for the class and you guys are not ready for the class. ठीक है, this is not the way. This is the only section, B section, with which I have this second time observed this rude behavior. ठीक है. This is very insulting for the teacher that teacher is waiting for 10-15 minutes and students are not coming. You should be here in the, you are not coming to the campus. You are just at your home. Why can't you sign in into the lecture at 1 o'clock? Why you need 10-12 minutes? Then why you are texting me, sir, why you are texting me कि sir attendance क्यों होगी? I know that there are 8 students waiting in the class now, but this is not the way. Okay, now next thing is we need to know that where is the shear cracks and where are the flexural cracks. There are two types of cracks that you will study in your PRC. One is the flexural cracks, other is the shear cracks. In the case of the flexural cracks, due to the loading, like 2-point loading or 1-point loading, which are also called as 3-point and 4-point loading. So under this loading, there will be flexural cracks which will be almost vertical, and they will be originating from the tensile side towards the compression side. They will be moving from bottom to the top because it is this beam will going to sag. So tension is at the bottom, compression is at the top. Concrete is weak in tension. So when the tensile stresses will become greater than what you say modulus of rupture, your beam will fail, or you can say the cracks will start to initiate. So cracks, once the cracks initiate, flexural cracks, they travel almost vertically, whereas your shear cracks, which are originated near the support. So these cracks, they travel at what you say at an angle of 45 degrees. So these are basically over shear cracks, and they are originating near the supports. Now, the thing is, the cracks in this concrete beam were caused by the tension stress, even though the beam was subjected to both an internal moment and the shear. The stress transformation equations can be used to predict the direction of the cracks. So you can see this, we can predict the direction of the cracks. And in general, your shear cracks are 90 degrees to the horizontal, whereas your flexural cracks are 90 degrees to the horizontal, and your shear cracks are 45 degrees to the horizontal. Now, these things at this stage, it's more than sufficient if you know what are the flexural cracks, what are the shear cracks, because at this like third year, you are just at the start of the concrete design. You are just studying the PRC1 and you will go with PRC2. So the cracks in this concrete beam, this beam is subjected to this is also called as 1-point loading or 3-point loading, whereas other loading is 2-point and 4-point. In 1-point loading, you will get a maximum bending moment. There is only 1 point which is maximum bending moment. In case of 2-point loading, you will get a region, a segment of the beam that will be subjected to the maximum bending moment. So the cracks in this concrete beam were caused by the tension stress, even though the beams were subjected to both an internal moment and shear. The stress transformation the stress transformation equations can be used to predict the direction of the cracks, and the principal normal stress is that cause them. Of course, if we can once use those equations, we can predict the orientation of the principal planes. And once we have the orientation of the principal planes, we know that principal stresses, major principal stress and normal minor principal stress, both these principal stresses act on the principal planes. Fine. So the stress transformation equations can be used to predict the direction of the cracks and the principal normal stresses that cause them. Now, how to get this one? To get the expression for the computation of major and minor principal stress. The first thing which you guys need to remember is that sigma 1 will always be your major principal stress. Sigma 2 will always be your what you say minor or minimum major stress. Okay? So sigma 1 is major principal stress, sigma 2 is minor principal stress. So whichever stress will be larger, that you will designate as sigma 1, and whichever stress will be smaller, you will designate it as sigma 2. Next thing is about this equation. Now, if you see this, this equation for the computation of major principal stresses, it is very much similar to equation number 1. Over equation number 1 was sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy plus tau xy sine 2 theta. So here, once we will put the trigonometric values of what you say cosine and sine, so your equation will become after simplification, your equation will become like this much. If you see this, this equation is now sigma 1 sigma 2, that is equal to sigma x plus sigma y over 2. So this part of the equation does not have theta, so it does not have a relationship what you say, there is no change over here basically. And in this second part, which was basically sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta, that part is basically your resultant or the radius. Over here at present we will say it's the resultant. Okay? Resultant of this triangle. Okay? So resultant of this triangle. So now we will get the expression that is sigma 1 sigma 2, that is equal to sigma x plus sigma y over 2 plus minus under root sigma x minus sigma y over 2 square plus tau xy square. Now sigma 1, to calculate the major principal stress, you will get the positive sign for the sigma 2, which is your minimum or minor principal stress. You will use the expression sigma x plus sigma y over 2 minus under root sigma x minus sigma y over 2 square plus tau xy square. So now you have two ways to calculate the major and minor principal stresses. First one, you can calculate the orientation of the principal planes, theta P1 and theta P2. Then you substitute the value of theta P1 in the equation number 1, or you can substitute the value of theta P2 in equation number 1, that is sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. You will get two values of the transform normal stresses. Because you are putting the value of the principal orientation of the principal planes, you will get major principal stress and minor principal stress. The second way to calculate the major and minor principal stress is this expression. expression which you will obtain by putting the trigonometric values of cos and sine, and then after simplification you have an equation that is sigma 1 is equal to sigma x plus sigma y over 2 plus under root sigma x minus sigma y over 2 square plus tau xy square, whereas sigma 2 will be sigma x plus sigma y over 2 minus under root sigma x minus sigma y over 2 square plus tau xy square. Now, depending on the sign chosen, this result gives the maximum or minimum in plane normal stress. So, depending on the sign chosen, this result will give us the maximum or minimum in plane normal stress acting at a point. Okay, always remember that the larger principal stress will be given or will be designated as sigma 1. Larger principal stress will be designated as sigma 1, whereas smaller or minor principal stress will be designated as sigma 2. ठीक है जी? So this particular set of values are called sigma 1 and sigma 2 values are called as the in plane principal stresses, and the corresponding planes on which these principal stresses are acting, they are called as the principal planes. ठीक है जी? Furthermore, we have studied that over the principal planes, your shear stresses will be zero. So the same the book is saying that if you will put the value of theta p1 or theta p2 in equation number 3, which we have derived for the computation of the transformed shear stress, that is tau x dash y dash is equal to minus sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So if you will put the value of theta p1 and theta p2 in this equation, you will get zero shear stress. ठीक है जी? That you might get very small value of the shear stress like 0.1 or 0.2. That is basically the rounding error. Actually, we must get the shear stress value as 0 over the principal planes. Shear stress 0 over the principal planes. Fine. If you have any question, you can ask me now. Next thing is this is the figure. This is over element. ठीक है जी? And this is your plane stress state. You have sigma x, you have sigma y, normal stress about x-axis, normal stress about y-axis, and the shear stress tau xy. So now this is your actual element which is oriented at an angle theta. In this case, the angle theta is theta p1. So now your theta p1 is the angle which is from x dash axis to the x-axis, which is over reference, and you can see this. So we have already said that difference between theta p1 and theta p2 is 90 degrees. So this is theta p1, this is theta p2. Fine. So the difference between the two angles is 90 degrees. So the normal stress about x dash axis is sigma 1. Normal stress about x double dash axis is sigma 2. And always remember that we will designate the larger normal stress as sigma 1 and the smaller of the two normal stress as sigma 2. So this is the final stage. Once you have calculated the orientation of the principal planes, you have calculated major and minimum minor principal stress, you have to draw the figure. You have to show the orientation of the principal planes theta p1, theta p2, and you have to show the normal stresses acting over it. So this was all about principal planes, orientation of the principal planes, and computation of major and minor principal stresses. Now, next is we have to calculate the maximum in plane shear stress. Maximum in plane shear stress. How we will get this maximum in plane shear stress? How we will get this? Anyone? So to calculate the maximum in-plane shear stress, what we will do, we have now equation number 3. Equation 9(2) is basically over equation number 3 for the computation of the transformed shear stresses tau x dash y dash that is equal to minus sigma x minus sigma y over 2 sine 2 theta plus tau xy plus tau xy cos 2 theta. ठीक है जी, तो x dash y dash is equal to minus sigma x minus sigma y over 2 sin 2 theta plus tau xy cos 2 theta. So what you will do, you will take the derivative of this equation with respect to theta, and then you will equate this. Then you will equate the derivative equal to 0. Fine, and after simplification you will get this equation. Guys, please do this yourself, and afterwards I will let you know how to do it. So this was the derivation for the computation of orientation of the principal planes, which we have done earlier. So this was the earlier derivation which we have already done. If you have, you can also keep this equation in mind while doing the derivation of equation number 3. Please do it and let me know. Take 2-3 minutes to do it, and then let me know the expression. You guys, how many of you have been able to find the derivative and then equate it equal to 0 and then simplify it to get this expression? How many of you? How many of you have been able have done this? Just one student? Okay, so this is our equation number 3. Tau x dash y dash is equal to minus sigma x minus sigma y over 2 into sine 2 theta plus tau x y cos 2 theta. So derivative of this equation with respect to theta is minus sigma x minus sine sigma y over 2. Derivative of sine is cos. So sine 2 theta derivative is cos 2 theta into the coefficient 2. Plus tau xy. Derivative of cos is minus sine. So derivative of cos is minus sine. So tau xy cos minus sine 2 theta into the coefficient 2. So after simplification, it will become, the derivative will become minus sigma x minus sigma y into cos 2 theta minus 2 tau xy sine 2 theta. Then equating it equal to 0. Fine. And then simplifying, we are going to take this coefficient on the other side. So it will become positive sigma x minus sigma y into cos 2 theta is equal to minus 2 times tau xy sine 2 theta. Then sine 2 theta over cos 2 theta, we will rearrange the coefficient. So sine 2 theta over cos 2 theta is equal to minus sigma x minus sigma y over 2 times tau xy. Then for next thing is that we know that tan is sine theta over cos theta. So tan 2 theta is sine to theta over cos 2 theta, and that is equal to minus sigma x minus sigma y over 2 times tau xy. So this is your equation for the computation of the orientation of the shear planes. Now the thing is that you can have a subscript theta with the theta as S1 and S2. The other important thing to be noted here that there is a negative sign, so which means that either one of them is negative and other one is positive. So please do this derivation and then I will go back to the question. Okay, so this equation now we have got, and if we represent it on the in this form, you can see this that this equation is giving me the negative value of the tan, which means the tan will be negative. So it means in quadrant 1 we know tan is positive. In quadrant number 3 we know tan is positive. So tangent is negative in the second quadrant and in the fourth quadrant. Tangent is negative in the second and fourth quadrant. So now you can see this in the second quadrant 2 theta s1. So over here you can see this shear stress is positive tau xy, whereas normal stress, average normal stress is negative because it's on the negative x-axis. Then in the second case, in the quadrant 4, you have shear stress is negative, whereas the normal stress, average of the normal stress is positive. Okay? So you have 2 theta S2, 2 theta S2, and again you can see that the difference between 2 theta S2 and 2 theta S1 will be 180 degrees. Important point is one of them, either sigma x minus sigma y or 2 times tau xy, either of them will be negative. ठीक है जी, one value will be negative, other will be positive. In case of the principal stresses, these both terms were either positive or negative. ठीक है. So the two roots of this equation, theta S1 and theta S2, that can be determined from the shaded triangles. So these are the shaded triangles shown in the figure. So now if you compare it with equation 4, which was tan 2 theta p is equal to 2 times tau xy over sigma x minus sigma y, the equation to compute the orientation of the principal planes, then you can see that this equation and the equation 9.4, the relationship between these two equations can be developed. Okay, so tan 2 theta p is basically 2 times tau xy over sigma x minus sigma y, and equation 9.6 is minus times sigma x minus sigma y over 2 times tau xy. So it means the relationship between equation 9.4 and equation 9.6 is that tan 2 theta s is the negative reciprocal of tan 2 theta p. Please note down this thing, and equations are in front of you, so you can see this, that equation 9.6, which is tan 2 theta s, it is the negative reciprocal of the tan 2 theta p. Furthermore, this equation will give you two roots, theta s1 and theta s2. So the difference between theta s1 and theta s2 is 90 degrees, where the difference between 2 theta s1 and 2 theta s2 is 180 degrees. ठीक है जी? The difference between 2 theta s1 and 2 theta s2 is 180 degrees. Furthermore, the difference between theta p1, difference between theta p1 and theta s1 will be 45 degrees. This we can prove from the from the numericals, ठीक है जी, or from the Morse circle very simply. Other thing is the difference between 2 theta s1 and 2 theta p1 will be 90 degrees. Difference between theta s1 and theta p1 will be 45 degrees. Similarly, difference between theta p2 and theta s2 will be 45 degrees. So each root theta s is 90 degrees from 2 theta p, and the roots theta s and theta p are 45 degrees apart. This is an element subjected to maximum shear stress. So you have seen, I have explained in the figure as well, that shear stresses are 45 degrees to the principal stresses. ठीक है जी? Principal shear stresses are 45 degrees from the position of an element that is subjected to the principal stresses. So after you have computed the orientation of the shear planes, the next thing is to calculate the maximum in plane shear stress. Next thing is to calculate the maximum in plane shear stress. Now the thing is that in that case, in the computation of maximum in plane shear stress, you have two options. Option one, you have the values of theta s1 and theta s2. Equate the values of theta s1 and theta s2 in equation number 3, ठीक है, or equation 9.2. You will get your values of maximum in plane shear stress. Remember this, the expression which will give you the positive value, that will be your maximum in plane shear stress. Other way around is that you find the sines and cosines of cos 2 theta and sin 2 theta, trigonometric values of equation 3 or equation 9(2). ठीक है जी, and that is basically will after simplification you will get the resultant. So over here your equation will for a maximum in plane shear stress will just simply be equal to the resultant of your triangle. So maximum in plane shear stress is under root sigma x minus sigma y over 2 square plus tau xy square. So the value of maximum in plane shear stress as calculated from this equation is referred to as the maximum in plane shear stress because it acts on the element in the xy plane. ठीक है जी? So just the maximum shear stress can be found by finding the trigonometric values of 2 theta s and cos 2 theta s in equation 9(2) or equation 3. You will get this maximum in plane shear stress which will be just equal to the resultant. ठीक है जी? Other thing is that substituting the values of sin 2 theta s and cos 2 theta s in equation 1, that is sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. You will get the average normal stress sigma average sigma x plus sigma y over 2. The point I want to reinforce here that in case of principal planes, over the principal planes you will get the principal stresses. However, on the shear planes, you will get the maximum in plane shear stress and the average normal stress. Okay, you will get these two things. So this is the short summary they have written. So all these points we have covered. Now after the break we will have a 15 minutes break, and after the break we will start with the numericals. Please after the break bring your calculators and the pages so that you can solve this numerical. Should we start the numericals?
Yes, sir.
Okay.
Yes, sir.
Okay, let me start the recording. Again, we have just 24 students in this class. Good. In the other classes, we have attendance close to 40, and in B section, we have attendance close to 24. Okay, so now we have the formulas for the computation of the orientation of principal planes, shear planes, and the computation of major principal stress, minor principal stress, and maximum in plane shear stress. So now we will do the numerical. So the numerical is that the state of the plane stress at a failure point on the shaft is shown. So this is the shaft and this is the plane stress element. You can see this plane stress element over which there are two normal stresses and one shear stress. So you have normal stress sigma x, that is minus 20 megapascals. You have sigma y 90 megapascals, and shear stress you have 60 megapascals. ठीक है जी. Only thing to be noted here, the shear stress is positive 60 megapascals because the vertical component of the shear stress is pointing upwards, so it is positive. Sigma y is 90 and it is positive as it is pointing towards positive y axis. Sigma x is negative as it is pointing towards negative x-axis. So we have minus 20 megapascals. ठीक है जी. Now question is very simple, that represent this stress state in terms of the principal stresses. So means I have to calculate orientation of the principal planes, and then correspondingly I have to calculate the sigma 1 and sigma 2, and then on the rotated element I have to show this or represent this stresses. Fine. So guys, let's start this question. First of all, please calculate theta. Use this formula, tan to theta p is equal to 2 times tau xy over sigma x minus sigma y. Please do it. Gee guys, what's the value of theta p?
minus 23.47 degree. 74 degree, sorry.
Good. Minus 23.74 degrees. Okay, so this one value is negative, so it is the smaller value, and because sigma 1 will always be your larger normal stress, and sigma 2 will always be your smaller normal stress. So sigma theta p1 must give us sigma 1, and theta p2 must give us sigma 2. So the negative value, it's assumed that it's the smaller of the two theta values, so that's why you are using the subscript p2. Okay, is that clear? That why we are using, see, in the general equation in the book as well, they are not using any subscript with p 1 or 2, but once they found that it is the negative value and it's the smaller of the two most probably values, so that's why they are using p2. Okay, now theta p2 is minus 23.74 degrees. Now the next thing is we have to calculate theta p1. As earlier we have said that the difference between theta p1 and theta p2 is 90 degrees. What we have said, that the difference between theta p1 and theta p2 is 90 degrees. यही कहा है ना जी हमने. Please find the value of theta P1. Theta P1 is
66.26 degrees, sir.
okay. The point to be noted here, guys, is that the difference between theta P1 and theta P2, it should be 90 degrees exact. Okay, so we had theta P2 as minus 23.74 degrees. So theta P1 must be 66.26 degrees. Okay, the difference between the two must be 90 degrees. Fine. Now, once we have the value of theta P1 and theta P2, please put these values of theta P1 and theta P2 in equation number 1, which we have derived, which was this equation. I have found it. Sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta. Please put first value of theta P1 and let me know the answer. Then put the value of theta P2 and again find the answer. जी जी What's the value of sigma 1 and sigma 2? Larger of the two normal stresses will be major principal stress sigma 1 and the smaller of the two normal stresses will be minor principal stress sigma 2. Please let me know the answer. जी
Sir, sigma 2 is minus 46.39 megapascal.
Okay. And sigma 1?
116.39 megapascal.
116.39 megapascal. Exactly correct. I also have the same answers with me. Okay, now next thing is we have to represent this on the element. So your theta P1 is 66.3 degrees, theta P2 is minus 23.7. Minus represents minus represents clockwise and positive represents counterclockwise. So this is counterclockwise 66.3 degrees. This is clockwise 23.7 degrees. So now we have to represent, you can see that your major principal stress sigma 1 is along the theta P1. Okay? So this is your x dash axis and this is basically now your x double dash axis about which you have this sigma 2. Okay? So the major principal stress must be along the theta P1 and the minor principal stress must be along the theta P2. Okay? Is this fine? Is this fine, guys? If you have any query, please ask me now. जी. If no query, then there is one another check they have applied, that we have said that over the principal planes, over shear stress will be zero. So if you put the value of theta P1 or theta P2 in our equation 9.2 or equation number 3, which we have derived, we should get zero shear stress. Can you do that, guys? Can you do that, please? Ayan 2929, please switch on your camera. Ayan 2929, please switch on your camera. अपने register दिखाएं what you have done so.
Okay, sir. Sir, can I send you a picture? I think my camera is not working.
Why it is not working?
I don't know, sir. Sir, I'll send you a picture.
Engineer Ehtesham. Hassan Sajjad.
Yes, sir.
जी अपना show me your register. What you have done. Okay. So let's do the next numerical. That is the same data which was given earlier. The same data will be now used to represent the stress state in terms of the maximum in-plane shear stress and associated average normal stress. So we have to represent this stress state in terms of maximum in-plane shear stress and associated average normal stress. So we need to calculate the orientation of the shear planes. We have to calculate then the maximum in-plane shear stress and the average normal stress. So again, the same data, sigma x minus 20, shear stress tau xy 60 megapascals, and sigma y is 90 megapascals. Sigma y is 90 megapascals. So we have to first calculate the orientation of the shear planes, that is tan to theta s. So guys, please calculate tan to theta s and let me know. So please calculate theta s1. What's the value of theta s1? Kitna value? What's the value we are getting, guys? Guys, you are doing it really very slow. Hanji? Okay, and theta s2? 255. Preferably just go to maximum 2 decimal places. 3 decimal places for angle is too much. Okay. My decimal places are sufficient. So theta s1 I'm getting as 111.3. Then theta s2 I'm getting as 21.3. Now next thing is we have to put the values of theta s1 and theta s2 in the equation number 3 to calculate the what you say maximum in plane shear stress. So when I put the value of theta s1 1.3 degrees in equation number 3, ठीक है जी, that is tau x dash y dash is equal to minus sigma x minus sigma y over 2 sin 2 theta plus tau xy cos 2 theta. So what value of shear stress, transform shear stress you got? जी, what value of transform shear stress you get? Megapascals. Now this is not maximum in plane shear stress because it is negative. So we with theta S2 21.3, please calculate the transform shear stress and let me know the value. Good. So this is the maximum in plane shear stress. The other way around is we can other way around is you can directly calculate it from here. So can you please calculate? So from this expression that the maximum in plane shear stress or maximum in plane, you must get the same answer. The next thing we have to calculate is the average normal stress. Average normal stress, that is sigma x plus sigma y over 2. So sigma x is minus 20 megapascals, sigma y is 90 megapascals divided by 2. Minus 20 plus 90 is 70, 70 over 2 is 35 megapascals. So our average normal stress is 35 megapascals. And then we have to represent this on the figure. You can see this is 21.3 degrees rotation counterclockwise, then 111.3 degrees. So the difference between theta S1 and theta S2 on the element is 90 degrees. So this is your positive shear stress. Positive shear stress, maximum in plane shear stress. And the average normal stress, you can see this, they are representing it here. Average normal stress, the stress about x dash and y dash axis. So please note down these two figures as well. One more thing I want to show you quickly. This one. So this is all what you have done in example 9.3 and 9.4. You had sigma y 90 megapascals, sigma x minus 20 megapascals, tau xy 60 megapascals. So you calculated tan 2 theta p and theta p1 66.3, theta p2 is minus 23.7. Then you have calculated the maximum and minimum principal stress. Sigma 1 you got as 116.39 megapascals. Sigma 2 you got as minus 46.39 megapascals. Then using your equation number 1, putting the value of theta P1 and theta P2, you can again get your maximum and minimum normal stresses. ठीक है जी? In the second case, you have calculated tan to theta s. Theta s you got as 111.3 degrees. Theta s2 you got as 21.3 degrees. Maximum in plane shear stress, tau maximum you got as 81.39 megapascals. Then putting the value of theta s1 and theta s2 in equation number 3, which we have derived earlier, I got this value of minus 81.4 megapascals, and with theta s2 21.3, I got the value of 81.4 megapascals. Average normal stress we got as sigma x plus sigma y over 2, that is 35 megapascals. If you see this figure, this red color is your orientation of the principal planes 23.7 and 66.3. These green lines are your orientation of the shear planes 21.3 and 111.3. There are few things which we need to check here. We have said that the difference between theta P1 and theta P2 is 90 degrees. 90 degrees. Difference between theta S1 and theta S2 is 90 degrees, and this is 90 degrees. The difference between theta P1 and theta S1 should be 45 degrees. It is 45 degrees. The difference between theta P2 and theta S2 should be 90 degrees. Sorry, difference between theta S1 and theta S2 should be 90 degrees. So this is 90 degrees. The difference between theta P1 and theta S1, this is exactly 45 degrees. The difference between theta P2 and theta S2, this is again exactly 45 degrees. Is this point clear? This was what I was telling you a short while ago, that the difference between theta P1 and theta S1 should be 45. You can see this angle, this is theta P1, this is theta S1, this one. So the difference of these two is 45 degrees. 111.3 minus 66.3, so 45 degrees. Then the difference between 21.3 and 23.7, 23.7 is 45. You minus that because it is clockwise. Take your time. If you have any query, you can ask me. Is it clear? If it is clear, then next thing we are going to do is Mohr circle. So let me share those slides. Just a moment. Okay, guys. Now let's start with the Mohr circle. Okay. Now, the difference between Mohr circle and what we have already done. See, to calculate the orientation of the principal planes, we have derived the equation. To calculate the orientation of shear planes, we have derived the equation. To calculate the principal stresses. To calculate the shear stresses, maximum influence shear stresses, we have the equations. Then we have derived the equations for the computation of transformed normal stresses, sigma x dash, sigma y dash. Then we have derived the equation for the computation of the transformed shear stress tau x dash y dash. Then we have the equation for the calculation of average normal stress. So we had 8 equations now. We have 8 equations now. Now, in case of Mohr circle, for all this, what I have just said, for all this, you have just one circle, and from that circle, we can get all these values. We can get the orientation of principal planes, orientation of the shear planes, principal stresses, shear stresses, transform normal stresses, transform stresses, average normal stress. So Mohr circle is basically much more simpler and easier to do. And let's start with Mohr circle. I want to give you some basic understanding of the Mohr circle so that tomorrow we can further study about the Mohr circle and we can solve some numericals related to it. So in this section, one more thing before starting, you are seeing Mohr circle plane stress. We will be studying Mohr circle for both plane stress and Mohr circle for plane strain. Okay, we will be studying Mohr circle for both plane stress and plane strain. So in this section, we will show how to apply the equations for plane stress transformation using a graphical solution that is convenient to use and easy to remember. Moreover, this approach will allow us to visualize how the normal and the shear stress components weigh. Just like in your regular x and y axis, you know that each point on the plane or on the in the graph, let's say, has a particular set of x and y values. Okay, has particular set of x and y values. Similarly, your normal stress here will be your horizontal axis, and your uh, this shear stress will be your vertical axis. You can see this, the shear stress is about the y-axis, normal stress is about the x-axis. So every point will have a particular set of sigma x and tau x, y. Guys, just give me a moment for this interruption. So each point on the Mohr circle, it will have particular value of sigma x and tau x, y. So now let's start how the Mohr circle principle works. So there are two main equations, 9(1) and 9(2). This is your equation 1, this is your equation number 3. So what they have done, this is the same equation, sigma x dash. Only difference is this part, which was earlier on the right hand side, they have moved it to the left hand side. So this is basically sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. And equation 3 is tau x dash y dash is equal to minus sigma x minus sigma y over 2 sin 2 theta plus tau xy cos 2 theta. Now, these are your two main equations. So how they have started? So these equations are written in the form that the theta coefficients with theta, they are separated out, and the values without theta, they are separated out. So the values without theta, they have moved it to the left side, and the values with the theta, they have moved it to the right side. Okay, so sigma x minus sigma x plus sigma y over 2 is equal to this cos 2 theta plus tau xy sin 2 theta. Similarly, tau x dash y dash is equal to minus sigma x minus sigma y over 2 sin 2 theta plus tau xy cos 2 theta. Okay, so this is just rearranging the coefficients. So now then what we are going to do, we will take the square of each equation and then we will add the equations. We will take the square of each equation and then we will add these two equations to eliminate the theta. So take the square, इसका square लें, ठीक है जी? sigma x dash minus sigma x plus sigma y over 2. Take the square of this, 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 and then add them together. So you will get sigma x dash minus sigma x plus sigma y over 2, this one square, plus tau x dash y dash square. And once you will add the square of these two quantities, you will get this answer, sigma x minus sigma y over 2 square plus tau xy square. You get it? And if you closely see this, this is actually your resultant. ठीक है जी? Resultant, this one. So this is over. So this is over resultant. Guys, can you see this? This was the resultant about which I am talking. Sigma x minus sigma y over 2 square plus tau xy square. So this is the resultant. Now, in that equation, you will see there is no square root. There is no square root. It's just square of this and square of this. So now it means that part. So now you see sigma x minus sigma y over 2 square plus tau xy square. ठीक है जी? So now if we simplify this, sigma x dash, this sigma x plus sigma y over 2 क्या है जी? This is your average normal stress, which we have just said that it will also be there on the shear plane. So sigma x plus sigma y over 2, I am replacing it with sigma average. Square of this plus tau xy dash square. And this one is my resultant, sigma x minus sigma y over 2 square plus tau xy square. This is your resultant, but because there is no square root, so this is basically r square now. ठीक है जी? So now this is the basic working principle, you can say, equation which your Mohr circle is dependent, on which your Mohr circle is dependent. Sigma x dash minus sigma average plus tau x dash y dash square is equal to r square. You can see sigma average is sigma x plus sigma y over 2. R is under root sigma x minus sigma y over 2 square plus tau xy square. If you have any query about this equation on which your Mohr circle is dependent, please let me know. Please let me know if you have any query about this part. No queries? So this is the basic working principle of your Mohr circle. So let's come to here now. How to draw the Mohr circle, that I can explain you now. Now over here there are few differences which you also need to note down. First of all, this is your vertical axis, which is your shear stress. Vertical axis is shear stress, horizontal axis is normal stress. This is your vertical stress, which is shear stress, and horizontal is your normal stress. Along the normal stress, if it is towards the positive x-axis, it is positive. If it is towards the negative x-axis, it is negative. Okay? The same as we have with the regular x and y-axis. But with the shear stress, it is different. The shear stress is considered positive downwards. Shear stress is considered positive downwards where the shear stress upwards is negative. ठीक है जी? So this is the first difference. Please note this down. That shear stress is positive downwards in the Mohr circle and it is negative upwards. So we establish the coordinate axis. ठीक है जी? Sigma positive to the right is positive and shear stress positive downward is positive. ठीक है जी? So now if you have the plane stress state, first thing is you have to calculate the average normal stress. Average normal stress is sigma x plus sigma y over 2. ठीक है जी? So this point is also over this point C, which has coordinates average stress and zero. Average stress, this is basically x-axis, so this is average normal stress. The shear stress is zero. So this will give me the center point of the circle, the center point of the Mohr circle. Okay? Origin is this one, 0, 0. This is the center point of the Mohr circle whose coordinates are average normal stress and zero shear stress. This is your center point of the, this is your center point of the circle. Fine. Next thing is I need to calculate the radius. The radius of the Mohr circle is same as the resultant, that is under root sigma x minus sigma y over 2 square plus tau xy square. Okay, so I can get the radius. So once you have the center point and you know the radius, just place your compass at the center point, open it equal to the radius and draw the circle. Open it equal to the circle radius and draw the circle. Okay? Fine? Cannot find. No response. Good. Is this clear? Are you guys in the class or not?
Yes, sir.
ठीक है. Clear है?
Yes, sir. Clear.
Okay. So you have the center point, you have the radius, you have drawn the Mohr circle. Now see what you can find from the Mohr circle. First, let me explain this C. So this is your average normal stress. So average normal stress sigma x plus sigma y over 2. This is one arbitrary point they have drawn, that this is your radius and this is one arbitrary point P. It has coordinates sigma x and tau xy. Okay? And it is positive because it's pointing towards the positive sigma and it is pointing towards the positive shear stress. So its coordinates are sigma x, tau xy. Okay? Now average normal stress is sigma, average is sigma x plus sigma y over 2. Okay? Shear stress is tau xy. Now the thing is sigma y. Where is sigma y? सिग्मा y कहां पे? Where is sigma y? Where is sigma y? Actually, if you see this, if I extend this line exactly back, so sigma y is somewhere here, from here to here. This is sigma y. ठीक है जी? This is sigma y. That's why you can see the average of sigma x and sigma y will bring me here to the center. Point to be noted here that earlier we have said that the difference between sigma x and sigma y was on the element 90 degrees. ठीक है जी? Element पे 90 degrees difference था between sigma x and sigma y. But once you see this Mohr circle on the next page, yes, here they are showing you sigma y. Now you can see the difference between sigma x and sigma y on the Mohr circle is 180 degrees. So the point you have to note down here that थीटा ऑन द एलिमेंट इससे कहते हैं, दिस इज एलिमेंट, ठीक है, दिस इज मोहर सर्कल, थीटा ऑन दिस एलिमेंट इज इक्विवेलेंट टू 2 थीटा ऑन द मोहर सर्कल। डन, ये पॉइंट पे नोट कर लें। First point which you had to note down, that shear stress is negative upwards in the Mohr circle. The second is theta on the element is equal to 2 theta on the Mohr circle. ठीक है? Done. Now, so now we know what is sigma x, sigma y, what is sigma average, what is this, what is this, what is this. That everything you can do. Now see from the Mohr circle why it is convenient. We have said that shear stress will be zero over the shear planes. ठीक है ना, हमने shear stress will be zero over the shear planes. So it means this is my shear plane. So it means this is my principal plane over which shear stress is zero. ठीक है जी, over the horizontal axis. You will only have the value of the normal stresses. Your shear stress will be zero. So now this is my principal planes. So with reference to this CP, I can calculate this angle to theta P1 and I can get the value of orientation of the principal plane. Furthermore, I know that the larger value of the normal stress will be my major principal stress and the smaller value of my normal stress will be my minor or minimum principal stress. So this is my major principal stress, this is my minor principal stress. Okay. Then I have said that over my shear plane, ठीक है, over my shear plane there will be two things, maximum in plane shear stress and the average normal stress. Okay, so you can see you can have the maximum value of the shear stress here and right here. Over here the maximum value of the shear stress will be negative, over here the maximum value of the shear stress will be positive, and this is the point of average normal stress. So it means my shear plane is this one over which I have maximum in plane shear stress and the average normal stress. So it means my shear plane is this one. So I can again calculate its orientation moving from this reference line CP towards this direction. So this is my shear plane. So I will get the 2 theta S1. Okay. So you can see from the Mohr circle, it is so simple to calculate the major principal stresses, minor principal stresses, orientation of the principal planes, orientation of the shear planes, maximum in plane shear stress, average normal stress. Now, earlier we have said that each point on the Mohr circle represents a particular set of normal and shear stresses. So now if let's say your theta is 40 degrees, okay, over the Mohr circle it will be 80, 2 times 40, 2 theta hai aapka on the Mohr circle. So this is your reference line CP. So moving in, let's say counterclockwise direction, you will using the protractor you can mark 80 degrees, and where it cuts your Mohr circle you can measure or you can note down the normal stress and the shear stress. Let's say next I want to find the value of 100 element oriented at let's say 80 degrees. So on the Mohr circle it will be 160 degrees. So somewhere here. So I can get the value of I can I can get the value of what you say sigma x and sigma sorry, I can get the value of sigma x and tau x y. ठीक है जी? Any questions? So all these points on the Mohr circle, they are basically your what you say have particular sets of what you say normal and shear stresses. Any questions about the Mohr circle, guys? If you have any question, please let me know. Any questions? No questions. No questions, guys. If you have no question, then guys, that's it for today. And inshallah, I will see you guys on Thursday tomorrow. Let me stop the recording. Attendance I have already taken off your class, and tomorrow we will continue with this. 18 students in the class. Okay, guys, thank you.